Hello and welcome, ladies and gentlemen, to the group exhibit Hydrogen Fuel Cells and Batteries at the Hannover Fair 2018. I invite you to sit down here, order a drink and enjoy the next interview. My name is Falco Haag and I will lead you the next 20 minutes through our following talk. Our interview partner will be Mr. Josep from Aperam, one of the global player in stainless steel, and there he is export manager for the company Stainless Steel and Specialties. Mr. Beer will now speak with us about continuous coated stainless steel, which is used for bipolar plates and PEM. Please welcome Mr. Beer.
Hi Falco, how are you?
And to the audience, if you have any specific questions, just raise your hand and I will come with the microphone to your place and you can just join the discussion. All right, Mr. Beer, at first, Aperam is a big company. What are Aperam's markets and products in general?
Okay, actually we have to keep in mind that Aperam is a steel maker. At the very beginning we sell stainless steel for different markets, mainly for automotive market, but also for white goods, for building, whatever it's necessary, where is necessary the stainless steel.
Okay, thanks. The bipolar plate can be made of different material. Why do you think stainless steel is the right material for these plates?
Okay, right. Here we are going to display a little presentation meanwhile we are speaking. And we will see that for sure a stack has some bipolar plates. These bipolar plates can be done in graphite or in titanium, but those products are not allowing this material for mass production, and it's not a really cost-effective product. So, in our case, Aperam tries to put on the market a product which is green, cost-effective, and it's going to allow to mass production and commercialization as well.
Okay, so I understood that the material you produce is now allowing mass production of bipolar plates, what was not able with other products before?
Actually, what we have to bear in mind is that stainless steel, and we'll see it later, the product it's a pre-coated stainless steel, so it's going to allow the production very fast, and the other products or are not cost effective or they doesn't allow this gain of time.
Okay. Not all of our visitors are experts in fuel cell technology. What exactly is the role of bipolar plates in a fuel cell?
Okay, here we can see in the next slide that the bipolar plate has some performances to do with the hydrogen, for example, and given to this performance to do, the stainless steel needs to face some requirements. The requirements that stainless steel needs to face, it's for example in terms of welding, in terms of shaping, in terms of electrical properties, but we know that stainless steel has what we call a passive layer. So this passive layer, it works very well for corrosion, but on the other hand it is not electrical conductive. That's the reason why we have to put a coating on stainless steel.
Okay, so what are the exact technical requirements that stainless steel with this additional layer fulfills?
For example, we need, here we will see, I'm going to stand, we need, for example, a good conductivity, electron conductivity, and it's going to be fulfilled by the stainless steel. Thermal conductivity as well. Okay, it doesn't work, doesn't matter. Also, we have to be resistant against corrosion, and we have to weld the bipolar plate, and we have to shape. Yeah, I see it here, but I don't see it there. Okay, it doesn't matter. And it has to be cost efficient. So this stainless steel is going to answer to all these requirements. But as I've said before, in terms of electrical conductivity, thanks to this passive layer, which is going to work very well for corrosion, it's not electrical conductive. So we put a coating on that it's very electrical conductive.
And on your slide there, I can see at cost efficiency there is an X. What's the reason, or what was the reason for this X?
What do you mean?
The cost efficiency on the right side with coating is not green but red.
Okay.
What's the background there?
Okay, yeah. You mean about the coating? Okay, the coating actually, for example, long time ago we were using gold. Gold, we know it very well. It's an expensive material, so we cannot do it with that. We have titanium as well, but it's also expensive. So, in order to make a cost-effective material, we produced a new type of coating. That's the reason why there was an X, but there is no an X anymore.
Okay, yeah. Then can you tell us about your new trademark? Can you say more about Aperam's strategy at all?
Sure. Actually, you see, we have a new product with a brand new trademark, which is Ion. This is the name of our new product, which is the solution from Aperam. The solution from Aperam was to take a coating with properties which are similar to the stainless steel, but with very high electrical properties. And why is it cost effective? Because Aperam took the strategy to choose the pre-coated material. So it means that in terms of logistics, we will see it later, it works very well. We use also existing mill. It means two things. We don't have any investment to put on the table, first thing. Second thing is that we are already industrial. This is not related to R&D. This is industrial product. And we work on existing coatings as well. So we try to develop a better performance in terms of electrical conductivity and so on. And this is the result. Ion is the result of all these choices.
Okay, and how long are you already working on this product? Can you already deliver material for mass production?
Actually, yes. This material has been done for, actually we have more than 10 years of R&D, but we produce it for years right now, and we are facing OEMs and we are facing other type of customers, so we are currently producing and delivering this material.
Okay, and which is the advantage of pre-coated material for the companies that produce stacks?
For example, we have two different types of material. We have what we call pre-coated and what we call per batch. Pre-coated, it means that we have the coil which is already coated, and later we are going to shape or stamp the material. So we are going to have better logistic cost, because the conventional method, you have to take the coil, to stamp it, to shape it, take the bipolar plates, send it for a coater, coat it plate by plate, and take it to your facility as well. So this is in terms of logistics, we are going to earn money, but also in terms of productivity. But because our line has a high speed, so we can produce a lot of meters in a very thin, in a very tight.
In a short time.
Yeah, in short time, exactly. Thank you. Also, we have different type of material that we can run from 75 microns up to 75 microns, and for sure, it has an efficient coating thanks to this line that we already have. So these are mostly the advantages of this material.
Great. And now I can imagine that companies ask for different sizes or even different properties of the pre-coated material. What can you answer to them?
Okay, good question. Actually, for sure, we are speaking about a product called Aeon, but we say that it's an agile solution. Why? Because we are able to supply different widths. We are able to supply different grades in terms of stainless steel, and even if you want, and we are facing some customers that depending on their requirements, we can modify the coating with different generations that you can see there, and we can offer the best coating that you need depending on your requirements.
Okay, next question is about electrical properties. How do they look like after adding the conductive layer then?
This is an important thing to underline. We know that we have the DOE standard, and the DOE standard is about less than 10 micro ohms per square centimeter, and our product is half of this target. And here you have different colors, and now I need to go there, sorry. But in this case, we have different colors because the first measure, it's done once the material is coated. So we are going to take the width of the coil and we are going to measure it. So this is the first line. Later, we are going to do a electrochemical test, which is the red line as well. And we are going to measure it. We see that we still, the value is very low. Later, we are going to make a post-shaping measurement, which is green. And again, we have a very low value. And after a stack test, which is not done by us, it's done by our customers, it's also measured. And we see that after a stack test, the figures are very low as well.
So does that mean that the pressing and stretching of the material does not influence the conductivity?
Actually, yes. For example, here, it is important to understand that there is a coating on the stainless steel. This coating is going to give the electrical conductivity. So this coating has to be continuous, for sure. This is the case. We see that it's very continuous. It has to be homogeneous. We cannot have a lot of variation, for example. It has to be adhesive. The adhesion has to be very, very strong because we are going to work these plates once they are cutted, and the adhesion is a strong point. Etc. It has to be columnar, and in terms of properties, you can see here that it works extremely well.
Okay, this is a nice example how the coating looks like before and after the shaping.
After the shaping, it's different.
No, this is before the shaping, right?
This is before shaping, and after shaping.
Okay, now after.
Yeah, because this question comes every time. Okay, you have a pre-coated material. And what's happening with the coating? For sure, the coating, the behavior of the coating is not exactly the same as the behavior of the stainless steel, so we can face some cracks on the coating. But here you have, for example, in this part of the bipolar plate, you see that there are some stretched parts. So the corner. So we take a look of this corner, and we see what happened. So we saw that there were some cracks, but when you analyze these cracks, you see that there is the passive layer. Okay, the passive layer is at your left, so it works against corrosion. In the center, we see that there is no detachment of the fuel of the coating, so it means that there is no fuel cell medium penetration, and the coating in the third photo is still constant. Okay, this is a concern about our customers, but we have different generations.
Yeah, of course, customers might be concerned about cracks in the coating, and you said that the picture we saw here is the point where the maximum stretching takes place, because you are interested what the maximum breaks, where the maximum breaks happen. What were your latest improvements on this now? Because your new product is different now.
Yes, exactly. If you come to our booth, you will see that we have different coils with different colors. Different colors means that we have different coatings. And as I said before, you have seen that we have different generations on coatings. So it means that depending on the concerns or the requirements of our customers, we are going to modify the chemical composition of the coating in order to find a coating which is following the behavior of a stainless steel. So with this new generation, the last one, we cannot say that there is zero cracks, but we can say that we are near zero cracks, knowing that it's in the most stretched part of the bipolar plate. So it means that everywhere there's no cracks, and you can have very, very few. And if you come, I can show you some photos of the coating, and you will see that there's almost zero cracks right now.
Great, great. I have an additional question. Your portfolio includes stainless steel for plates and fuel cells, but what about PEM in electrolyzers? The technical requirements like conductivity should be similar.
Actually, in terms of electrolyzers, this material is not going to be exactly the best one, because in terms of thickness and in terms of coating, it's not going to be the material chosen. But we have other, in our portfolio, we have other stainless steel, but we speak more about ferritics in that case, K41, K44, which are more adapted to this type of market.
Okay, so both potential customers are welcome at your booth, I guess.
Sure.
And because you told right now that you can show Aperam's brand new trademark Ion, the pre-coated stainless steel, especially developed for these PEM fuel cells, you can show afterwards in detail.
Yeah, sure. If someone is interested, we are just beside. And we can show you the different coils. You will see one coil. It's interesting to see that it's already a production product for us. This is something that we can sell tomorrow. You will see a small coil. You will see it's golden. The color is golden. It doesn't mean that it's gold. It's close to electrical properties of gold, but not the same in terms of price. Okay.
Okay. Thank you very much for this interview, and thank you in the audience for joining us here. Booth number is 62/1.
Okay. Thank you very much. Thank you. Thank you.
Okay, and next interview on stage will be the business development opportunities and supply chain development for hydrogen and fuel cell companies in Connecticut. See you there.